Welcome to today's lesson. So today's lesson is on cost efficiency and payback time. So the aim of the lesson is to understand that different insulation comes at a price and to be able to calculate the payback time. So just like before, you're going to need the assignment next to you, ready to fill out the questions throughout the video. So first of all, you need to pause the video and work your way through the Do Now activity. Okay, so the first one, you should have got that double glazing windows help trap air and reduce heat loss by conduction and convection. A lot of heat loss is lost from the roof because hot air rises due to convection currents. Cavity wall insulation involves filling the gaps with foam, which traps air, reducing conduction because air is a poor conductor.
So, now we've seen these three different methods of heat transfer, let's put them into action a bit and see if they can save some money on your heating bill. So, if we look at a typical house, there are loads of different ways that house can lose its heat energy. One of the big ways, as you can see, is through the roof. That's obviously because hot air rises, so that's going to be the warmest part of the house. So one thing you can do to reduce your energy bill is put some loft insulation in. Now, what loft insulation is, it's normally something made of fiberglass, and the reason this is good is it traps lots and lots and lots of air in tiny little pockets. The reason that's good is because air is a very bad conductor of heat, and if air is trapped in really tiny pockets, it's so small that convection currents can't form. So this will stop convection and massively reduce conduction. Okay, what else can we do? Well, there's actually a big cavity between your walls. So your outer walls of your house have two layers of bricks with a big cavity in the middle. Now that's good because it's full of air, which is a bad conductor, but it is at the moment it's big enough for convection currents to form. So what you can do, you can get cavity wall insulation. Essentially they pump a load of foam in with lots of tiny air pockets, so no convection currents and really bad at conducting. Another thing you could do, look at all that heat going straight out your windows. Pop in some double glazing. Again, the way this works, trapping air between two panes of glass, really bad conductor. One of the last things you could do is put in some draft proofing, the cheapest way to reduce your energy losses. All you do is you put some plastic sort of strips around your windows and doors, stopping all the hot air escaping. All of these ways of reducing heat loss cost money. And
Okay, so we now want to look at the advantages of installing insulation. So the first one is that more energy efficient. So because the thermal energy leaving is reduced, we're conserving heat. The next one is because energy is conserved, less fuel is needed for heating, and therefore less pollution from burning fossil fuels. And finally, because less heating is being used, more money is saved. However, house insulation involves buying the required materials and installing them. This costs money. We can work out how cost effective the method of insulation is by looking at the payback time. Payback time is the amount of time it takes to cover the cost of installing the insulation with the annual savings of heating the house. So essentially, how quickly it takes for them to pay for themselves. So payback time equals insulation cost over annual savings. Insulation annual savings is measured in pounds and payback time is in years. You now need to pause the video and fill up the spaces on the assignment. We're now going to do a series of I do, we do, you do activities. Remember, during an I do activity, make sure your pens are down and you're focusing what I'm doing in the video. Okay, let's start with step 1. Floor insulation costs £140 to install but saves £70 annually. What is the payback time? So as you can see from step 1, I'm going to circle the insulation costs and the annual savings. Step 2, write down the equation for payback time. So payback time equals installation costs over annual savings. So I now want to substitute the values into the equation. So as you can see, our installation cost is £140 and our annual savings is 70. I want to calculate this value, which would be 2. And as step 5, I need to remember the units. So payback time is in years. Okay. During the We Do activities, I need you to pause the video at each step and write down what you would think to do for each step, and then carry on playing the video. So, loft insulation costs £300 to install but saves £150 annually. What is the payback time? So first of all, I'm going to circle the insulation cost and then the annual savings. You should have done this before carrying on the video. So step 2, pause here. I'm going to write down the equation for payback time. Okay, pause the video again and substitute the values into the equation. So this would be 300 over 150. Pause the video and calculate the value. This value would be 2. And step 5, remember to write your units. So for payback time, it's years. You're now going to pause the video and work through the You Do examples, and then come back. Okay, draft proofing costs £60 to install but saves £40 annually. What would the payback time be? So look at your answer and check it against this one. You should have got 1.5 years. Okay, the double glazing for a house cost £3,000 but saved £150 per year in fuel costs. Calculate the payback time. Again, check your answer against this one. You should have got 20 years. Okay, the next few questions are slightly differently. This is an I do, so put your pens down and focus on the video. So the cavity wall insulation in a house costs £6,000 to install. It has a payback time of 15 years. How much money does it save on fuel each year? So I'm going to first start with circulating the installation costs and the payback time. So I now want to work out how to rearrange the equation to work out the annual savings. I can do this by drawing a triangle. So payback time equals installation costs over annual savings. So now I want to work out what it would be to work out the annual savings. So I'm going to cover up the annual savings, and it would be installation costs over payback time. So now I'm going to write this out. So for step 3, I'm going to substitute my values into the equation. So it would be 6,000 over 15. This should equal 400. So I need to remember the units. So annual savings is in pounds. If I want to check this, I can put it back into the original equation to see if it works. So payback time, 15, should equal 6,000 over 400. So I'm going to type it into my calculator and see if it works. And it does. So it means we've worked it out correctly. So following the same as before with the we do, pause between each step and to write down what you think you would do. So the double glazing window costs £2,500 to install. It has a payback time of 10 years. How much money does it save on fuel each year? So I'm going to start by circling the installation costs and the payback time. And again, if you want to draw the triangle to work out how to rearrange the equation, you can. So rearrange the equation now and come back to the video. So annual savings equals installation costs over payback time. So now pause the video and substitute the values into the equation. So you could have got 2,500 over 10. Pause the video and calculate the value. Should have got 250. And step 5, remember to write your units. Should have got Again, you can substitute the answer back into the first equation of payback time equals installation costs over annual savings to see if you've got the answer correct. You now need to pause the video and work your way through the you do examples. Okay, the floor insulation for a house costs £1,200 to install. It has a payback time of 4 years. How much money does it save on fuel each year? So I've started by circulating £1,200 and 4 years. And I've followed step 2 and rearranged the equation and then substituted my values. So 1,200 over 4. And you should have got £300 for your answer. Okay, so following exactly the same method for this question, the draft proofing costs £50 to install. It has a payback time of 1.5 years. How much money does it save on fuel each year? So after circulating the installation cost and payback time and writing down the equation, I've substituted the values, so 50 over 1.5. This should have given you 33.33 reoccurring, which I've rounded to 33.30. And I've added the unit, so it'd be 33.3 pounds. Okay, check your answer against this one. You should have got £150. Okay, this one is another I do activity, so make sure you're watching the video and not doing anything else. So double glazing has a payback time of 15 years and saves £120 a year. What was the cost of its installation? So I'm going to circle the annual savings and its payback time. And drawing the triangle again, I'm going to cover up installation cost to work out what the equation would be. So you can see that installation costs will equal payback time times annual savings. So my step number 3 is going to be substituting these values into the equation. So it would be 15 times 120. I'm then going to calculate this, and it should be 1,800. Okay, I need to remember my units. So again, it's going to be pounds. I can put this answer into our first equation to check if it's right. So payback time, 15, should equal 1,800 divided by 120, which is correct. Okay, so there's another we do activity, so remember to pause the video before each step. So step number 1 is to circle the annual savings and payback time. And then need to write down the equation. You can again join the triangle if it helps. Now I'm going to substitute the values. And I'm now going to calculate this, which would be 255. And remember the units would be pounds. Again, I can put this into the first equation to work out if I'm right. So 1.7 equals 255 divided by 150. So I'm going to put that onto my calculator and see if it's correct. Which it is. So you now need to pause the video and go through the you do examples. Okay, floor insulation has a payback time of 2.5 years and saves £70 a year. What was the cost for insulation? Working through all the steps, you should have got £175. Okay, cavity wall insulation has a payback time of 2.3 years and saves £115 a year. What was the cost of insulation? For this one, you should have got 264.5. So finally, draft proofing has a payback time of 0.7 years and saves £50 a year. What was its cost for insulation? So I've worked through all the steps and I've just used shorthand for the equation, and I substituted it to find £35 for the insulation cost. So if you got all those right, really well done. So we're now going to work through some exam questions. Okay, so we're going to start by highlighting parts of the question. It's really important to highlight the important parts of the question to make sure you don't miss out any key information. So the house cost £800 per year to heat. The homeowner installs loft insulation, which saves her 25% on her annual energy bill. The payback time is 2 years. How much did it cost to install? Okay, so from this, we know that we're trying to work out the installation costs. So if we write down the equation for this, we know it's installation costs equals payback time times annual savings. Okay, so first of all, we know the payback time is 2 years. So we've got that. we need to work out the annual savings. And it says here that it saves 25% of her annual energy bill. And we know that her total is 800. So we need to find 25% of £800, which is going to equal £200. So then we can then substitute our values. So payback time is 2 years times 200 equals 400. And to check that we've got this right, we can put it back into the equation. So payback time, 2 years, should equal 400 divided by 200, which it does. So here we've got the installation cost is £400. So our next question is, properly insulating a house can help reduce the amount of carbon dioxide in the air. Explain why. So I want you to think back about the advantages, and I'll try and answer this question. I'm not going to go through this one, but I'll check your answers later and give you feedback. Well done for concentrating in this lesson.